Hi guys, let's do an interesting word problem from the Common Core or the Engage website. And I also want to go back in time before we had calculators. And let's do this like we don't have a calculator. So back in time, back in time. Okay, so we got this problem here. It says your family is redecorating the dining room and wants to place two rectangular, so you should always draw a picture. When they say something visual, you should draw the picture. Two rectangular wall sconces, they're lights, that are 25 inches wide, so they labeled this 25 inches wide, along a 10 2/3 foot wall, so that the distance between the lights and the distances from each light to the nearest edge are all the same. These are all the same. We're going to need to label this stuff because that one wasn't labeled. Design the wall and determine distance. Hey, listen, symmetry defines beauty. Look it up. They always say that Halle Berry has a very symmetrical face. That's why she's so beautiful. So when you go to put something on a wall, it's nice to have it symmetrical. Okay? So one of the hardest things that you probably didn't recognize when we read this, I'm going to underline this. And see if you can figure out what is making this question even more interesting. We have 25 inches wide. Labeled right here, and then the wall is 10 2/3 feet. See if you could say it before I tell you. 25 inches, 10 2/3 feet. Those aren't the same units. We can't play like that. We got to have the same units, kind of like terms. They're not alike. So we got to decide. We got to make a decision. Are we going to use inches or are we going to use feet? So this part of the picture was labeled, but we didn't label this. We should put an X somewhere. What was the question? Determine the distance from each light to the nearest edge, which is, I don't know that. And remember, it said that all of these are the same. So then what's this one? It's also X. And what's this one? It's also X. Oh, I decided I wanted to use Y. I guess I wanted to be different, so I'm going to change this to Y. The Y is the variable, and Y is the distance, if you look back at the word problem, measured in. Well, I don't know what's measured in yet, because we got to make that decision. So let's do some converting. And my favorite way to do conversions is with a proportion, because we can solve almost every Math 7 question with a proportion. We can solve the majority of Math 7 problems with a proportion. So let's stick with the tool that works for everything, an all-in-one tool. So proportions are two equal ratios or two equal fractions. So I got my bars and my equal sign. And then I need to write down my units. I've got inches and feet. So let's start with the 25 inches. So I put inches on top. So I'm going to put 25 here. 25 inches is an unknown amount of feet. And then what do you know about inches and feet? 12 inches in 1 foot. Okay, first we label. Then we substitute the numbers in to match the labels. And then once we have a proportion, we cross multiply. 25 times 1 is 25. 12 times x is 12 times x. Write the times in here if you want. To get the x by itself and isolate it, we're going to undo multiplication with division. We're going to divide by the coefficient. And remember, I asked you not to use the calculator. This divides off to 1x. And then let's go really old school. I'm going to draw the box. The divisor is knocking on the door. 25 goes in the box. So I always say the top goes down and the bottom goes outside the box. How many 12s go into 25? Well, one would be 12. Another 12 would be 24. So if I do 2, that's pretty close. 12 times 2 is 24, and I get a remainder of 1. So if you remember, that's going to be 12 holes and 1 out of the, not 12 holes. I said 2. My bad. Fix that. 2 goes in twice with 1 out of 12 left over. And what were the units? Let's go back and look. The X was in feet. So this is feet. That's 1 out of 12 would be 1 inch because inches are in 12. So that's 2 feet and 1 inch. But I don't want to mix feet and inches. So in completely feet, it's 2 and 1/12 feet. It's a little weird to say, but I'm right. Okay, so I don't know how I feel about that. Let's do this again. We're going to write a proportion. I'm going to label it inches and feet. Doesn't matter where I put it.
May I have your attention, please?
Okay, so I got my inches and my feet. I put the 10 2/3, which is feet, lined up with the feet section. And for that amount, I don't know. So I got X, how many inches that is. And I still know that there's 12 inches in 1 foot. And once I put the labels in, then I put the numbers in, then I cross multiply. This one's pretty easy. X times 1 is X. And then I got 12 times 10 2/3. I'm going to use distributive property. 12, check it, check it, check it. 12 times 10 2/3. 12 times 10 is 120. I'm going to need some workspace. 12 times 10 is 120. And 12 times 2/3. Remember, we're going old school, okay? So this is a 12 over 1. Numerator times numerator, denominator times denominator. Numerator and denominator are separated by divide. So 12 divided by 3 is 4, and 4 times 2 is 8, and 1 times 1 is 1. This is 8. 3 goes into 12. 4 times multiplied by the 2 that's still there is 8. So I got 120 and an 8, so it's 128. And the units, remember, we were solving for, let's go back and look, the X is near inches. Now you're like, I could have used a calculator for all this, but I just went over like a bunch of chapters. So this is like a cool review. So I got 120 in inches. Now remember, we were supposed to make a decision. What would you like to work with? Would you like to work with the number 2 1/12? Or would you rather work with a regular old whole number, 128? Did that sound like a biased question? Because it was. Let's use the whole number. Let's do this in inches. So we're changing stuff to inches. So I got 10 2/3. I'm going to change to inches. So this is now 128 inches. So now it's all in inches. We're all in the same units. We're all on the same page. Now we can do this. I need to solve for y. I need to figure this out. Now if you look at this picture, this part of the wall is the same length as this part of the wall, right? So what would be the length of this rectangle written in terms of y, meaning with y's in it? What do you see? I see a y and, which means plus, a 25, and another y, and another 25, and another y. There's the complete total length of the wall written in terms of y. So I need to solve now. I'm going to go to my bottom of my page here where it says solve. We're going to write the equation. I have those two things that are equal. The whole wall is 128 inches, and in terms of y, it's y plus 25 plus y plus 25 plus y. Can we write that simpler? You best believe I could simplify that. How many y's we have? 1 y, 2 y's, 3 y's. 1 plus 1 plus 1 plus 1 is 3. And then I got these, you notice I'm using a different shape. Then I got two 25's, which makes 50. Oh, that's way simpler. Okay, I'm running out of room, so I'm going to rewrite it. I got 3y and 50 equal to 128. I simplify before I solve. That's as simple as it gets. It's time to solve. Reverse with the inverse. We're going to attack the 50 first because we go after adding and subtracting before we go after multiplying and dividing. The opposite of the 50 that's bothering Princess Y here is a minus 50. You have to do it to both sides. Drop it like it's hot and see what you got. 128 minus 50 is 78. Then we're going to divide both sides by the coefficient, which is 3. because division is the opposite of this times, and these will divide off, so I have a singular y. And then, remember I said we're not using the calculator, so where do I want to put my work? 3 goes into 78. 3 goes into 7 twice. You get 6. You subtract. You drop the 1. Drop the 8. 3 goes into 18. 6. So I get 26. And the units are... What are the units? This was, and this was, and this is inches. So I got 26 inches. Now, I would like to know what that answer is in feet also. And I want to show the work for a conversion. And I know a lot of people don't always do the proportions. They revert to like elementary school methods of, well, I know I'm supposed to multiply, or I know I'm supposed to divide because it's easy. So instead of just assuming, at least make a table. We got inches and feet. So I want to know what 26 inches is in feet. And I already know that 12 inches is 1 foot. So if you show me a table, I can at least see your reasons why you multiply or your reasons why you divide. So here's the reason. If I'm going from 12 to 1, I need to divide by 12. So because I'm going in the same direction, I'm going to divide this by 12. How many times does 12 go into 26? 12 goes into 26 2 times. You get 24 with 2 left over. And that's not a 0.2. It's not 12. It's not. This answer is not 2.2. Because it's not 2/10. This is not 2/10. It's 2/12. So don't just change everything to a decimal, because decimals count by tenths or tens. So it's 2 and 2/12. Okay, some more old school stuff. 2 and 12 have a common factor of 12. So I can reduce that to 2 and 1/6. So 2 and 1/6 is my final answer for feet. Okie dokie, thanks for the trip down memory lane. Got any questions? Let me know. You got another problem to do on the other side. It's actually a lot easier than this one. So remember, you start from the beginning, you underline important information, you make a video. I'm not a video, I make the video. You make a picture, you label your picture, and then you do all this other work. By the way, none of these steps would have been written for you if this was a state exam. I like to write the steps to try to help you to focus. So when you're doing these questions on your own, try to make a plan and make some steps and lay them out and do them one thing at a time. A problem like this is a pager. It's going to take you a whole page to do the problem. So it's a lot of work. Plan out your steps. Okay, see you on the flip side.